I want you to close your eyes for a second.
Unless you're driving, maybe.
Right, yeah, if you're driving, please keep them open. But picture a bridge, just a standard, massive, concrete highway bridge you'd cross every morning.
Okay.
For the last 50, 60 years, that bridge has been, well, for lack of a better word, dumb.
A rock.
Just a rock. A concrete, steel, rebar. It just sat there, took the weight, didn't say a word. Maybe once a year, a guy in a hard hat would come out, tap it with a hammer.
The old percussive maintenance check. Classic.
Exactly. Low tech, reliable, but dumb. But today, that bridge it's changing. It's waking up. We're embedding sensors deep in the concrete now, sensors that can feel stress. It's got monitors that know exactly when the wind's blowing too hard. It has a brain, a literal processor sending signals back saying, hey, I'm hurting over here.
It's a massive shift. I think waking up is the perfect way to describe it.
We aren't just building with concrete anymore. As our source material today puts it, we are moving from concrete to cognition.
And we are effectively giving the built world a nervous system, which, on paper sounds like a sci-fi utopia. Bridges that talk, power grids that heal themselves.
But, and there's always a but on this show, that is exactly our mission for today's deep dive. We're looking at the hidden risks of this so-called smart infrastructure.
Right.
We've got a stack of research here, mainly anchored by this really comprehensive analysis from Johan Steyn. He's an expert in AI and smart tech, plus some pretty alarming reports from late 2025.
And just to set the stage, the goal here isn't to scare you. We're not fear-mongering.
No.
But we need to be realistic about the trade-off.
Right, because I love the efficiency of it. I love that my GPS knows about a traffic jam before I do. But Steyn's argument is that we're rushing to wire everything up without realizing that when you give a bridge a nervous system...
You also give it the ability to feel pain.
Or to be manipulated.
Exactly. When a system's dumb, you can't really trick it. You can't hack a pile of bricks without, showing with the sledgehammer.
But once that pile of bricks has an IP address...
It's a completely different ballgame.
Okay, let's get into the mechanics here, because the nervous system analogy Steyn uses is really helpful. He breaks it down into 3 parts: nerves, reflexes, and a brain. So the nerves.
Right. The nerves are your sensors. This is the whole Internet of Things IoT. So we're talking vibration sensors on railways, flow meters and water pipes, that kind of thing.
Eyes and ears?
They're the eyes and ears. They turn physical reality, heat, pressure, whatever, into digital data.
Which then leads to the reflexes.
And those are the automated responses.
Yeah.
It's the OT, the operational technology layer.
Like touching a hot stove.
Precisely. You don't think your hand just moves. So if a sensor says water pressure is critical, a valve automatically opens. It's instant. No human has to turn a wheel.
And then finally, the part that gets all the hype, the brain.
The analytics layer. This is the AI. The brain takes, say, 10 years of vibration data from that bridge and predicts, okay, based on this trend, that bearing is going to fail in 3 weeks.
So you move from reactive repairs to predictive maintenance.
Right. You stop waiting for things to break and cause a massive traffic jam.
Which is just huge economically. I mean, municipal budgets are always tight. The idea that you only send crews to the sick parts of your infrastructure, that's a game changer.
It's an economic necessity. A lot of our infrastructure, especially in the West, is aging. We can't afford to rebuild it all, so we use technology to squeeze more life out of it.
But this is where that double-edged sword comes in. Steyn points out that by creating this nervous system, we've created this massive new surface for attack.
And it's not theoretical. This isn't a movie plot.
No.
No, it's very real. And this is the oh no moment of the deep dive. We're in the era of the cyber-physical threat. In the old days, to take down a power station, you needed, explosives. You had to be on site.
Now you just need a laptop in a basement halfway across the world.
That's it. Every single one of those sensors, every gateway, every dashboard an engineer logs into, those are all entry points. Steyn calls it the attack surface.
And the more sensors you install, the more skin you have in the game to get cut.
And looking at these supplementary reports we have, especially from Reuters in December 2025, this isn't teenage hackers messing around.
No, we're talking about state actors.
The scale is completely different. The warnings from U.S. and Canadian agencies were specific about Chinese-linked actors. The name Volt Typhoon was in the news. But what's really chilling is their strategy. They weren't just smashing things.
They were doing something called pre-positioning.
Pre-positioning.
That sounds military, like planning for a future conflict.
It is military thinking applied to civilian infrastructure. Think of it like a burglar breaking into your house. But instead of taking your TV, they just unlock a window in the basement. or tape a spare key under the doormat, and then they leave.
So you come home and nothing is missing. Everything looks normal.
Everything looks perfectly normal. But they've made sure that if they ever want to come back 6 months from now and cause chaos,
they can do it instantly. They have persistent access.
that is the allegation. And Steyn highlights this as a fundamental shift. The goal isn't always immediate destruction, it's leverage.
It's a weapon held to the head of the economy.
If you know you can shut off the water in a major city with a keystroke because you planted that malware 2 years ago, that's a massive strategic advantage.
It really changes how you think about security, but it brings up a question I'm sure our listeners have. We have antivirus, we have firewalls, we've been securing banks for decades. Why is securing a water pump so much harder? Why can't we just install, Norton for dams?
I love that. But this gets to the absolute core of the problem. It's the conflict between IT and OT.
Information technology versus operational technology.
Exactly. We all know IT, that's your laptop, email, customer databases. In IT, the holy grail is confidentiality. You don't want data stolen. If there's a security patch, you schedule downtime at 2 a.m. on a Sunday, you patch it, you reboot.
Right. If my email's down for an hour, I'm annoyed, but nobody dies.
But OT is different. OT is the machinery, the turbines, the pumps, the assembly lines. In OT, the #1 priority is safety and uptime. You cannot just reboot a blast furnace.
It would ruin the whole facility.
Right. And you can't just patch a power grid in the middle of a heat wave.
So the IT security person says, we need to patch this now. And the OT engineer says, if you touch that system, the whole plant shuts down.
It's a huge culture clash. And to make it worse, a lot of this OT stuff it's legacy tech. We're talking about controllers that might be 20, 30 years old.
From before the iPhone, before the cloud?
They were never, ever meant to be connected to the internet. They speak old, insecure protocols. They don't have password protection as we think of it.
So it's like taking a 1950s truck and trying to drive it with a modern supercomputer.
That is a brilliant analogy.
The computer's trying to parallel park it at 60 miles an hour, but the truck doesn't have power steering or anti-lock brakes.
That's it, exactly. And that interface, where the shiny new AI meets the rusty old machine, that's where the hackers thrive. You're layering complexity on top of fragility.
There's another thing Steyn mentions, which I found fascinating. He calls it the visibility trap.
Ah, the digital twin problem.
We assume that because we have 1,000 sensors, we know what's happening. We trust the dashboard.
You're in a cool, quiet control room looking at 6 monitors. You're not looking at the actual water pump. You're looking at a digital representation of it. If an attacker can hack that data feed,
they can make the screen say, all good, while the system is melting down.
Or the reverse. And Steyn references a specific incident in Denmark mentioned by the Associated Press, a water utility. The attackers didn't just steal data, they left homes without water.
The kinetic effect, digital cause, physical effect.
Right. Now imagine you're the operator. Your screen might say a pump is running perfectly, but the water isn't flowing. Or it screams danger, so you panic and shut the whole system down. But the pressure was actually fine.
You just caused a blackout because the sensor lied to you?
It's industrial-scale gaslighting.
That's what it is.
And once an operator loses faith in their data, the whole system grinds to a halt. You're back to sending a guy in a truck, but you don't even know where to send him.
So what's the fix? We've got hackers pre-positioning malware, legacy equipment that can't be patched, sensors that might be lying. Is the answer more AI, an AI security guard?
You might think so. But Steyn argues for something much more fundamental. He calls it security by design. And honestly, it's kind of boring.
Boring is good. In this context, boring sounds very, very safe.
It is. It's not about buying a magic box. It starts with ruthless network segmentation.
Segmentation. So keeping the systems separate.
Building walls. There's absolutely no reason that your payroll system, where people are clicking on emails, should be able to talk to the system that controls the chlorine levels in the water supply.
But in the rush to get all that data onto the CEO's dashboard, I guess those barriers come down.
All the time. Convenience is the enemy of security. The other boring fix is just an accurate asset inventory.
Knowing what you own.
It sounds so basic, right? But in a sprawling city or factory, you'd be shocked. There are devices nobody even knows about. A maintenance guy installed a Wi-Fi router 3 years ago in a basement and forgot about it.
A shadow IT device.
And if you don't know it's there, you can't patch it. You can't secure it. It's an open window that's not on your blueprints.
It's like trying to lock your house, but forgetting about a skylight you haven't opened in 10 years.
Exactly. But the most critical point Steyn makes, and this is the big one, is about manual fallbacks.
Manual fallbacks, you mean? Going back to turning a wheel by hand.
Yes. We are designing systems that are so automated we're forgetting how to drive them. Steyn argues that for critical infrastructure, there must always be a way to disconnect the digital brain and move the muscles yourself.
So if the screen goes black or starts lying, can a human being physically go down to the valve and close it?
And this is the scary part. Does that human even know how to do it anymore? Do we still have the muscle memory? Or have we relied on the autopilot for so long we've forgotten how to fly the plane?
That's a huge question. We're training a generation of software operators, not mechanics.
And Steyn is clear that standards for this exist. This isn't the Wild West. You've got the IEC 62443 family of standards, guidance from the International Society of Automation.
So the instructions are there. We're just not following them.
We follow them when it's convenient. But security costs money. It adds friction, so corners get cut.
Which brings us to leadership. If you're a city planner or a CEO listening to this, Steyn says this is not something you can just dump on the IT department.
No, this is a governance issue. He lists 3 questions every leader needs to have an answer for.
Okay.
If you can't, you're being negligent.
Okay, let's go through them. Question 1.
Who is accountable for the risk? And I don't mean the CISO, the tech person. I mean, if the water stops, who owns that failure? The mayor, the CEO.
Right. Who's on the hook?
Okay, question 2.
Who can override automated decisions in an emergency? If the AI says, keep the valve open, but an engineer on the ground sees a pipe about to burst, who has the authority to say, no, I'm shutting it down?
The HAL 9000 problem.
I'm sorry, Dave.
I can't do that.
Exactly. We have to make sure we can unplug HAL. And the third question is, what is your incident response plan?
Not if it happens, but when. When the ransomware hits, is there a rehearsed plan? Or is it just going to be chaos? You have to run the drills.
Steyn also brings up an interesting point about the changing business landscape, referencing a tech cabal note from late 2025.
Yeah, this shows it's a global shift. Regulations are tightening everywhere. It used to be a company got hacked, they'd try to sweep it under the rug. Now, disclosure laws are forcing them into the light. If you lose control of infrastructure, you are legally required to report it. That changes the reputational stakes immensely.
So ignorance is no longer a defense, and silence isn't an option.
Exactly. And he warns about vendor lock-in, too. If you buy a smart sensor platform from a startup and that startup goes bust, what happens to your bridge?
You need the in-house skills to fix it if the vendor disappears.
Smart without clear authority is just connected fragility. That's the quote from the source that really stuck with me.
It's a powerful line. It sums up the whole argument. We're trading robustness for an intelligence that is itself fragile.
It is. And look, we're not saying don't build smart cities. We need them. We need the efficiency. But we have to stop treating cybersecurity as just an IT problem.
It's a civil engineering problem.
It has to be in the blueprint. You wouldn't build a skyscraper and say, oh, we'll figure out gravity later. You have to design the defenses before you pour the concrete.
So as we wrap up, where does this leave us? We have this incredible technology that gives our world a brain, but that brain can get sick, get tricked, get held hostage.
It leaves us with a responsibility. The nervous system metaphor is perfect. It's great. It protects you from a hot stove. But nervous system is also how you feel pain. It's a pathway for trauma.
And if you expose the nerves, you have to protect them.
You do. We need to value those dumb backups. We need to respect the manual override.
And here's a final thought for you to mull over. We're rushing to give our cities a brain, teaching the concrete to think. But as we hand the keys to the algorithms, have we remembered to keep a spare set for ourselves?
That is the ultimate question. In the quest for automation, we absolutely must not lose human agency.
So the next time you cross a bridge or turn on a tap, think about that invisible conversation happening inside the concrete. And just hope someone remembered to lock the digital back door.
Indeed.
That's it for this deep dive. Thanks for listening and stay curious.